Grind 75, C++. Let's do majority element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n over 2 times. You may assume the majority element always exists in the array. So this algorithm's a little bit contrived, but it's pretty neat, and it comes up in a lot of algorithms classes. So basically, the trick is, okay, so there's a follow-up. Could you solve the problem in linear time in O of 1 space? So let's talk about theoretical minimums. We're going to expect linear time to be our target because, well, how do you know something is the majority element? Well, best case scenario, you count up to n over 2 plus 1 items, and you say, okay, these are all the same. We know this is the majority element, and we stop there. Well, n over 2 is still linear. You know, there's a constant factor of half, but that kind of washes out when you write out the runtimes. So there's that. Now, how do you do it in O of 1 space? Well, kind of a naive approach is to just count every element, save their count values in a hash table, and then you scan that hash table for whichever one has the max. That would be linear space. And then that's also hashing. So, you know, maybe you might get I have had an interviewer asking me about complications with hashing. If you use a hash table in like an algorithms class, your professor will slap you in the face because those, the theoretical runtimes are much, 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 much worse than their practical real world runtimes. Like, really, they're like, I think they're theta constant time because that's our expected. But in worst case, they could technically be a linear time lookup with hash tables. All right, so how do you do this in constant space? Well, a trick would be, how do you have non-majority elements cancel out with majority elements? So let's write that out. I'll show you before I describe it with words. So there's going to be there's two parts. There's a counter and there's a for loop. Well, that's really one part. Anyway, so let me write out some variables. Int return, so ret for return, and then we have a counter. I'm gonna write CTR because it's a little smaller. The counter we're going to initialize with 1. Return I'm going to initialize with -1. And the -1 is just for errors. So for example, it doesn't, what's the minimum length? So n number, the length, so okay, nums is at least length 1 on these inputs, so we don't have to worry about an empty nums. Now, depending on the interview, they might want you to check for an edge case of like an empty array, and what do you return then? Well, I guess just a -1 for invalid. I don't know. So that would be an edge case to consider. All right, so we've got return value and we've got a counter. So let's, okay, actually return value. Oh, sorry, I don't even, if it was an edge case and like an empty input, then I would return -1, but I'm actually going to initialize it to the first element of nums. All right, so we have our main for loop. So for int eyes less nums dot size plus I. All right, so that's our loop, and then I'll punch out the return value before I forget. So how do we get this ret to be our return? Well, there's a couple of conditions. Actually, okay, so first of all, we initialize this return value to be the first element, so we're going to start a loop at the second element of nums. And what do? First, we're going to compare the value that we're currently at. So if nums I is equal to our return value. So, okay, if the return value, our current candidate solution, is equal to the current value, we're going to increment our counter. And if it's not, we'll decrement our counter. The idea being that supposing we never reset our counter, well, that won't. Sorry, if it's different, then we'll decrement the counter, and that way, like the counter is going to be 1 or more. That all being said, because it's equal increments, equal decrements, but we know that there's a majority element, so the counter is gonna be a positive value at the end. All right, so what do we do next? If we're decrementing, okay, actually there's one more condition to look out for. We're not gonna just decrement. What we also want to do is compare. So if we hit 0, we want to update our candidate solution, basically. So ret if our counter is 0, then our solution is updated. And we're going to set our counter back to 1. So that way, this way we have all of the non-majority elements canceling out with majority elements. And then let's give it a run. Okay, so actually first I'm going to write out the runtime and then step through an example. I think that would be the best way to illustrate how this works. So runtime, it's a for loop that covers almost the entire array, so O of n time for the for loop, and then O of 1 space for the counters and variables. We just have 1, 2, 3 integers that we're using, and that's pretty much it, constant space. All right, so example. Let's do the first one. So our input 323. We initialize our return value to 3. So a for loop is going to go from, all right, so return value initialized 3, counter initialized to 1. Now our for loop. So going from the second element to the end of the array, if the nums is equal to return, it is not. So we're not going to increment our counter. Instead, we're going to decrement it. Our counter goes to 0. So then what happens? We check that. That's true. So we're going to update our candidate. Our candidate is now 2, and we reset our counter to 1. All right, next iteration. Final element of the loop. Our num, okay, so nums is not equal, so 2 equals 3. That is not true. So we're going to go down to here. We're going to decrement our counter. All right, so our counter is now 0. So we're going to update our candidate again. So our candidate is again 3. And we update our counter to 1. But that's the last iteration of our loop. So we break, return, and we return 3. So that's the expectation. All right, so let me do. I'll do the other example too. All right, so we've got that one. It's a little bit longer. All right, so we're initializing to 2, and our counter initializes to 1. So with 2, if 2 is equal to 2, so that's true. We're still going to increment our counter. So now it's 2. Skip the else. So next iteration 1. So is 1 equal to 2? It is not, so we're going to decrement our counter. But our counter is still 1. It's not 0, so we're not going to hit this. Next iteration, another 1. In this case, our candidate is still 2, so we're going to decrement our counter again. It is now 0, so now we're going to update our candidate to 1. So we're at the second one. We got one more 1 to go after this, and reset our counter to 1. All right, and in this case, our candidate is equal to the final one, so we're going to increment our counter again. So that's 2. And now we're at this first 2. So we're expecting our final output to be 2. And if you see, we have 2 more chances to decrement our counter. So yeah. All right, so is 1 equal to 2? No, it is not. Decrement our counter. Is our counter 0? No, it is not. Next iteration is 1 equal to this 2 here? It is not. Decrement the counter. Our counter is now 0. So we're going to update our candidate to that final 2 and reset our counter. Now that we're going to use it because it's the last iteration of the loop. So we break, return, we're going to return 2. And that is our expected output. Let's give it a run for syntax. Cool, neat, submit. And accepted, and mark it off. Thanks.